All right, welcome back. Second to last lesson that you got to listen to my annoying voice. Yay! Almost done, seniors. I'm trying to think. I don't think I have any juniors. All right. Ooh, sorry about that yawn. Okay, you need to start copying down what I have here while I jibber jabber. This is a PERT. Notes on banking. So y equals CE to the KT. It's honestly just a PERT. They just want to change up the variables because a PERT really contains or is affiliated with doing it annually. This is banking where we're depositing, and now we can really talk about different rates at different times, whether it's daily, whether we're talking about a rate monthly. So really with this, you can use the variables a PERT. It really is the same thing. It's just we're often finding our rate, our K, and it talks about the growth versus the K or decay. And here we're talking about your rate being in months or your rate being in maybe not just years. So your time can change. So that's very important to look at, is the time not only being in terms of years. That's the only difference really. So jot that down, maybe pause it. Essentially everything's the same. Use y equals CE to the KT for if you deposit $200, so that's our C or your P, $200, and are trying to save over 8 years. So essentially that's our T. To have a total of $800, at what rate would you need to invest your money at? Okay, so essentially we're trying to find our K. So let's begin the problem. Our final amount, our Y, is going to be $800 is equal to our C, which is 200. E, we don't know our K, which is our rate again, times our T is our years, which is 8. So again, just like our other problems, divide by 200, divide by 200, 800 divided by 200, we're going to be at 4 equals e to the 8k. Now to solve for e, or to solve for k, because we have a base of e, we want to ln both sides, ln both sides. Remember, this cancels, and you end up with 4 ln 4, equals 8k. Divide by 8, divide by 8. Plug that into your calculator, and you should get k to be approximately 0.17328. That is not how I want your final answer written, and I will take off for that. I want you to then multiply by 100 to write it as a percentage. So k, your rate, is about, and round to the nearest, we'll say 10th-ish or 100th. Let's do 17.33%. There you go. Easy peasy, just like what we were doing before. All right. Number 2. Use y equals CE to the KT for if you want to know how much money you have to deposit into an account that has a rate of 3.5% in order to earn $950 in 7 years. So now we want to figure out how much do I actually have to deposit. So our final amount that we want is $950. We do not know how much we have to deposit. We know E. We know our rate. We have to write it as a decimal, so 0.035% over 7 years. Now, all I'm going to do is I am going to divide by E raised to the 0.035 times 7. Divide this by e raised to the 0.035 times 7. And c would be approximately, pause, you make sure you get the same answer as me, $743.57-ish. We're going to skip 3. It is just like number 1. You do get a negative rate. That is okay. So that is just saying it's decreasing. You should get negative 7.19%. That is just fine that you get a negative answer. 4, they're just giving you fill in the blank. Can you solve from that? So, given all the information, can we actually solve? Okay, easy peasy. Plug and chug. 8,000 equals 12,000 e to the negative 0.123t. All right, easy peasy. Divide by that 12,000. Divide by 12,000. So you get 2/3 equals e to the negative 0.123t. To solve for your power, you need to ln both sides. ln both sides. That will make this cancel. So now we have ln of 2/3 equals negative 0.123t. Now divide both sides by negative 0.123. Divide by negative 0.123. Plug and chug that lovely thing into your calculator. Maybe hit pause to make sure you're getting the same thing. And you should get t to be approximately 3.296. And we weren't given the units, so it's just 3.3 whatever units. Maybe years, maybe months, who knows. All right. 5. If C equals 6,000, K equals 0.158, how long will it take for the quantity to triple? Again, we talked about this the other day. For something to double, something to triple, we don't know our amount. So, that final amount. But if you're given that the original is 6,000, what is your final amount? Just multiply it by 3. You know that would be 18,000. So now you know you can set 18,000 equals 6,000 e to the 0.158 t. Divide everything by 6,000. Divide by 6,000. 3 equals e to the 0.158t. Now you could have actually started here because for something to triple, it would be 3 equals e to the whatever t. For something to double, it would be 2 equals e to the whatever t. Anyway, continuing. Now we need to solve this. We need to solve for our power, so you need to ln both sides, ln both sides. That drops. So now we have ln of 3 equals 0.158t. So let's divide both sides by 0.158. Divide by 0.158. Now pause it. Plug that into your calculator. T would be 6.953. Or t is approximately 7, whatever our units are. All right, we're going to skip 6 because we just did an example like that, so we won't waste our time. Let's look at 7. Suppose the population of a city is increasing continuously. That's how we know to use this formula, because it's PERT, a PERT, basically. Now we use the variables y equals c e to the RT. Do I care if you use a PERT? Not one bit. It's the same formula at the rate of 10% per year. Notice our problem is in years. If the population is in 1997 is 20,000, find the population in the year 2000. All right, so we don't know our final amount. That's what we want to find. So y equals, well, in 1997, it was 20,000. E, our rate was 10%, so that's 0.1. And in 2000, from 1997, that was 3 years. Plug and chug that into your calculator. Okay, population, should you have a decimal? Do you have a point like 4 of a person? Not what at all. So once you calculate it, you get 26,997.17. So essentially that is 26,997 people. All right, 8. The population of dolphin in this ocean is increasing at a rate of 9%. Now read this per month. Okay, so our units are changing. Okay, if there are 325 dolphin in the ocean February 1st, how many will there be on August 1st? Okay, so now you got to think of this. February, March, April, May, June, July, then August. Well, actually, you should probably do it the other way. Count February. That was my bad. Because all of February, March, April, May, June, July, then you get to August. That's not the month. So we have 6 months that we have to count. Because you go 6 full months. Okay? So now, we've got our formula. If there are 325, that's our starting amount. So y equals 325. E to the, our rate is 9%, so 0.09. That's our rate per month. So we are going over 6 months. Now, plug and chug that into your calculator. I got 557.7. In other words, y equals, we have at that moment 557 dolphin. Don't round it up. Last one, going back to your science class. The half-life of a radioactive element is the time it takes for 1/2 of the quantity to decay. Decay means your rate is going to end up being negative. If the half-life of an element is 50 years, so it's telling us our time, find the rate of decay. So half-life, for this, you should just know, you should set 1/2 equal to e to the kt. Just use that. That will be our half-life. So we have 1/2 equals e. We don't know our rate. We need to find that. But we do know our time, 50 years. So now we need to take the ln of both sides. ln. That's gone. So we've got ln of 1/2 equals 50k. Divide by 50. Divide by 50. Now, type that into your calculator. I get k to be approximately negative 0.01386. Now, don't forget you need to multiply that by 100. So k's rate should be negative. Move that over 9-ish %. There we go. Any questions? Well, I guess I'm so used to saying that.